Hello students, this third session of the chapter enzyme is explaining about enzyme kinetics, which means it is the quantitative measurements of the rates of enzyme catalyzed reactions. Enzyme kinetics is the quantitative measurements of the rates of enzyme catalyzed reaction. It also involves the systematic study of factors that affect these rates. About the reaction rate, overall study is termed as enzyme kinetics. It began in 1902 when Adrena Brown reported an investigation of the rate of hydrolysis of sucrose catalyzed by yeast enzyme invertase. Coming to the different factors which affect the rate of enzymatic reactions, there are mainly four factors, which are the concentration of enzyme, concentration of substrate, then pH of the reaction, and temperature. Coming to the effect of concentration of enzyme, at constant pH and temperature, if we consider, and if an excess of substrate is present, the rate of reaction is directly proportional to the concentration of the enzyme. So enzymes have extraordinarily catalytic power, that is a non-factor. A small amount of enzyme is enough for a large amount of substrate. Increase in the concentration of enzyme will increase the rate of reaction. If there is enough substrate and if we maintain a constant pH and temperature, the rate of reaction will be directly proportional to the concentration of enzyme. Increased number of enzyme molecules will have more active sites, thereby increasing the rate of reaction. Coming to the effect of substrate concentration, for a typical enzyme catalyzed reaction, the reaction rate initially increases very rapidly with substrate concentration. At low substrate concentration, it will be very slow, and after some time it will raise with substrate concentration. But once it reaches one particular point, the complete active site is blocked, afterwards there will not be any increase in the rate of reaction. When the substrate concentration is low, the reaction is first order. Then order with being proportional. At low temperature, at low concentration of substrate, it will be proportional to the concentration of substrate. Enzyme active sites are still free in the case of low substrate concentration, but when it is increasing, when the substrate concentration is increasing, the increase in rate of reaction begin to slow down. Now, at very high substrate concentration, no further increase in rate is observed. When substrate concentration is very high, afterwards, once all the active site of the enzyme is blocked, then there will not be any further increase in the rate of reaction. Coming to Michaelis-Menten equation, Michaelis and Menten propose that the enzyme catalyzed reaction involves the reversible formation of an enzyme substrate complex. That is, the ES complex, enzyme substrate complex, breaks down to form free enzyme and one or more product. That is, we can write as E plus S, that is, E stands for enzyme plus A substrate, reversible enzyme substrate complex, then which will degrade to form enzyme, free enzyme and product. The derived equation, both of them derived an equation which mathematically defines the quantitative relationship between the rate of an enzyme reaction and substrate concentration. This is called as Michaelis-Menten equation. This is that equation which is V equal to V max into concentration of substrate divided by Km plus concentration of substrate, where V naught, this should be V naught. V naught is the initial rate. V max is the maximum rate or velocity of the enzyme. Then concentration of S, that is substrate concentration. Km is the Michaelis-Menten constant. By knowing the Michaelis-Menten constant value of a particular enzyme substrate system, one can predict whether the cell needs more enzyme or more substrate to speed up the enzymatic reaction. Km is the Michaelis-Menten constant, which can be defined as the substrate concentration at half of the initial or half of the maximal velocity, that is V max, half of the maximum velocity. What will be the substrate concentration? That will be equal to Km. Km, that is Michaelis-Menten constant, can be defined as the substrate concentration at half of the maximum velocity. The lower value of Km, the greater the affinity of the enzyme for the substrate. A high value of Km, the lower the affinity of the substrate. That is the importance of Michaelis-Menten constant. Coming to pH of the reaction, how a pH will affect the rate of a reaction catalyzed by an enzyme. Most of the enzymes have a characteristic optimum pH at which their activity is maximum. At this pH, you can see in this graph, the reaction rate is increasing. It is reaching a maximum point and then it is coming down. It is different for different enzyme. So most of the enzyme have one optimal pH at which their enzymatic activity is maximum. At this pH, the catalytic groups in the active sites are in the catalytically more effective state of ionization or activation. Above or below this pH, there is a change from the required state of ionization and thus the rate is reduced. Above or below, this is a change, this is the graph. Above or below this particular pH, there should be a change in the state of the enzyme. At extreme pH value, the enzyme is inactivated due to denaturation. If there is a very high change in the pH value, the enzyme will be denatured or coagulated, which will not be functional anymore. Thus, on either side of the optimal pH, on both sides of the optimal pH, reaction rate decreases sharply. So, for each enzyme, there will be one particular optimum pH at which the reaction rate is very high. Coming to the effect of temperature, just like in the case of pH, most enzymes have an optimum pH, an optimum temperature, where the enzyme reaction, the catalytic reaction, the rate of the reaction is high. Most enzymes show an increase of 50% to 300% in reaction rate when the temperature is increased by 10 degrees Celsius. Just by increasing 10 degrees Celsius, there will be an increase in rate of reaction to 50% to 300%. This trend continues until about 45 degrees Celsius. After 45 degrees Celsius, when the temperature is raised above 45 degrees Celsius, then denaturation of protein enzymes sets in. The protein in enzyme will be denatured. So from this point, the reaction rate will drastically falls to 0. You can see in the figure, once it is reaching to maximum, then suddenly it denatured and it decreases its activity and the rate of reaction drastically comes down to 0. So these are the effect of these factors, which are enzyme concentration, substrate concentration, pH and temperature on the rate of enzyme catalyzed reaction. So in this session, we have seen about enzyme kinetics, a study of enzyme kinetics, different factors which will be affecting the rate of enzyme catalyzed reaction.